Hello, in this video we will learn how to solve this problem. This is on alternating current, parallel circuits. This is the circuit given. You see there is a capacitor, there is an inductor and AC source, all connected here in parallel. Also it is given current in this branch 0.7 ampere RMS value, current in this branch containing the inductor 0.9 ampere, of course RMS value, and you are supposed to find the current supplied by the AC source, which is I. You are supposed to find I. We will see how to do this. This one lagging current IL. So you call the current here as IL, that is lagging current, meaning the current in this branch containing inductor lags behind the voltage which is supplied by this AC source. So this is lagging current. The RMS value 0.9 ampere of the lagging current. Then here here in this branch containing capacitor, the current will lead the voltage. The current here will lead this voltage. And the RMS value, corresponding RMS value 0.7 ampere. So we can call this 0.7 ampere as the leading current. IC. We call them as IL and IC. Right? Next we move on to drawing the phasor diagram. Voltage shown here, say along the x-axis. Now lagging current means current lags behind this voltage 0.9 ampere here, which is the RMS value. So current lags behind the voltage means like this, IL. But here in this branch, current through this branch will lead the voltage. So you have to draw this way, IC. So there are two currents here. One is IC, the other one is IL. And this being a phasor diagram, you can find the net current. That will be the current supplied by the AC source. And to find the net current, it is IL minus IC. IL greater than IC. You can look at this 0.9 and this is 0.7. So you draw this a bit longer than this. So find the resultant now. IL minus IC. That is only I. You are given IL 0.9 ampere, IC 0.7 ampere. Therefore, I will simply be 0.9 ampere minus 0.7 ampere. Source, I is equal to IC. Substitute the respective values. IL 0.9 ampere, IC 0.7 ampere, 0.2 ampere. So current supplied by the source 0.2 ampere. Of course it is RMS value. We will consider one more problem of LC parallel circuit. Find the current in each branch and the current supplied by the source. This is a circuit given. The branch here contains only capacitor. The branch here contains only inductor. The AC source 110 volt, 50 Hz. 110 volt will be the RMS value. 50 Hz is the frequency. First we will find out omega value. Omega formula 2 pi f, omega angular frequency 2 pi f, f is 50, so 100 pi radian per second. Then use the formula for XL and XC. XL and XC formula we will use. For XC it is 1 by C omega, for XL it is L omega. XC is what? Capacitive reactance. XL is what? Inductive reactance. Is it okay? Okay. when you calculate Xc, 1 by C omega, C is 10 microfarad. Omega 2 pi f, which is 100 pi. We have already got it here, 100 pi. Simplify. 10 power 3, which is 1000 of course. 1000 by pi ohm. Look at the unit. Capacitive reactance 10 power 3 by pi ohm. Then similarly, using the formula of XL, we calculate inductive reactance, which will be 10 pi ohm. You know XL and you know XC. Construct the phasor diagram. But here you know XC, here you know XL. Before we go to phasor diagram, we find the currents in various branches. First we find, say, IC. IC is nothing but V by XC. Using Ohm's law as we apply for AC, VC equal to IXC. So I will be V by XC. Here that I only is IC. So IC is V by XC. IC V by XC. V value is this 110 volt. You see these two are in parallel. 110 volt here as applied to this capacitor. So V by XC. Put the values. .1 pi ampere. This V 110 for XC 1000 by pi or 10 power 3 by pi. That pi will go to the numerator here. Simplify, you will get 0.1 pi ampere, which is IC. Then calculate this IL using the formula V by XL. For V 110, for XL 10 pi. Okay. So 11 by pi ampere. 11 by pi ampere. What is that 11 by pi ampere? Current in the branch containing the inductor. Of course, RMS values, don't forget. Now we want to find the current supplied by the source. For that we need phasor diagram. So first we draw the phasor diagram. And here of course IL greater than IC. Look at these values, you will easily find out IL is greater than IC. Okay. Voltage phasor. Current through inductor. We know that inductor, the current through the inductor will lag behind the voltage. So IL should come this side. This is of course 90. Okay, 90. IC leading current. Because IL greater than IC, I have drawn IL little longer. Find the net current. IL minus IC. You know the values of IL and IC, simply subtract. Okay. So when you simplify, you get the final answer as 3.19 ampere. Okay. Understood? Thank you.